Hey guys, I have another math video for you today. While we are going over sine of I, you may think this will be trigonometric. This will be a fair bit of calculus. So, mainly, you need to know what Maclaurin series are, and you need to generally have a good intuition about messing about with really weird functions like these. Now to start, our preface. In order to actually solve this, we are going to need to know the Maclaurin series of these three functions right here. I'm going to hope you know the first two, so I'm just going to put them up. For sine of x, we know it's going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, and so on, so on, so on. For cosine of x, we know that's going to be 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial, on and on and on. And finally, e to the ix. Now, I'm going to assume you haven't been working with e to the ix, so let's figure this out. We know that inputting 0 is going to give us e to the 0, or it's going to give us 1. For the next term in the series, we're going to bring this I over as the coefficient to the next derivative, so we're going to have ix. Then we're going to bring the I over again, so our next value is going to become negative. It's going to become negative x squared over 2 factorial. After that, we bring this I over again, negative ix cubed over 3 factorial. And we can keep on going with this cycle. Bring that I over again will make this positive, giving us x to the 4th over 4 factorial. Then we bring I over again, ix to the 5th over 5 factorial, on and on and on. Now, if we look at these terms in the sequence, we see they're cosine of x. So we can say e to the ix is equal to some cosine of x plus something. Now, what the other something is, first of all, realize that there's an I in every single one of these terms, so we can bring that I out. But if you look at it, you're going to see that we're going to have x cubed over 3 factorial, x to the 5th over 5 factorial. This will actually give us I sine of x. This information is essential to know for later parts of the proof. So now, to get to the next part of the proof, we're going to have to represent cosine of I and sine of I in very unorthodox ways you might not have seen before. If you start getting lost in this, check the description, the document will help you out. First, cosine of I. If you remember the Maclaurin series, or check the doc for it, our first term is going to be 1. Then the next term will be minus x squared over 2 factorial. But I squared is negative 1, so that cancels out our negative and gets us plus 1 over 2 factorial. Now, after that, our next term is positive x to the 4th over 4 factorial, but that I to the 4th is just 1, so we get plus 1 over 4 factorial. Then we're going to do that same trick we did with the 1 over 2 factorial to get 1 over 6 factorial. Cosine of I is going to give us this sequence. Next, interpreting sine of I. Our first term is x, so we just have an I here. Then, minus x cubed over 3 factorial. If we remember, I cubed is negative 1, so this will actually give us negative I, my apologies, I over 3 factorial. I to the 5th is just regular old I, which means that our next term is going to be I over 5 factorial plus I 7 factorial if you do the work yourself, on and on and on and on. However, it is important to note that we can rewrite this as having I 1 over 3 factorial plus 1 over 5 factorial plus 1 over 7 factorial, blah 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 blah. Now, something important to note about this is that this series can be rewritten. If we look at it, we can rewrite it as this. 1 over 1 factorial minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial minus 1 over 6 factorial, blah blah blah, with all these canceling each other out. However, the observant eye will realize that this gives us 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial, on and on and on. We have this series running on and on. And this will give us this series minus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 4 factorial, on and on and on. This gives us this series right here, which is a representation of sine of I, or at least the part with I factored out. Looking closely at these, we realize that this gives us E, because this is the definition of E, the Maclaurin definition of E, minus, if we check this, with this, we see we get the exact same sequence. To get E minus cosine of I, which means that finding sine of I is going to be finding I E minus cosine of I. Now, knowing that sine of I equals I E minus cosine of I, we can use this definition for substitution to help with finding sine of I. Now, if we remember, e to the ix is equal to cosine of x plus I sine of x. If we input I for x, we're going to have e to the negative 1, because remember, I times I equals negative 1, which, for mental convenience, I'm going to write out as 1 over e is equal to cosine of I plus I. We're going to get sine of I, so we can substitute that with the sine of I definition here. I e minus cosine of I. This is going to simplify to 1 over e equals 2 cosine I, because remember, this is going to become negative 1, which is going to make this negative positive, and because we have 2 cosines of I, we can add them together, minus e. Now, bringing this over and bring it into the same group, the same denominator as the number over here, we're going to get 1 plus e squared over e, because remember, e times e, is going to equal 2 cosine of I. Flipping this around, this means that we can find cosine of I to be exactly e squared plus 1 over 2e. With the knowledge of cosine of I, we can start simplifying sine of I. For convenience, you'll see later on, we're going to make the sine of I divided by I equals e minus e squared minus 1 over 2e. We can simplify this by making this e to have the denominator 2e, giving us sine of I over I equals 2e squared minus e squared minus 1 over 2e. Simplify this down to sine of I over I equals e squared minus 1 over 2e, and bring this I back around to find that sine of I equals e squared minus 1 over 2e I. Now to make this formal, and that's the video. I hope you enjoyed it. I hope you actually learned something. I know this was structured very confusingly, especially if you had no calculus experience, so please, 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 I implore you, if I can, to go check the doc for any simplification mentally that you might need. There will be a deeper explanation of how we derived the Maclaurin series, and it will be very nice and colorful this time compared to the other dull Google Docs, but besides that, I hope you have a wonderful day.